Okay, so far I'm not doing so good with the faster than chapter 4 or chapter 5 test, but no, but that's just the way it is apparently. Um, so 3 through 6, solve them by using substitution. We have to use substitution on these because they don't have like terms. You can't use elimination if you can't cancel out like terms. So we have to use substitution. So again, pick a variable and solve for it. Try to avoid having to take square roots. Try to avoid having to do almost anything complicated when solving for the variable you choose. This x is by far the simplest, nicely isolated variable, so solve for it. Subtract the 2y, subtract the 2y, and you get x equals negative 2y. So x and negative 2y are supposed to be the same thing, so they should be interchangeable. So in the other statement, 2 times x, well, x is supposed to be interchangeable with 2y. So where there's an x, let it be 2y, negative 2y. That's being squared minus 3y squared equals 5, and solve that for y. Just like substitution, except there are squares involved, so we have to use substitution. 2 times negative 2 squared is 4y squared minus 3y squared equals 5. So 8y squared minus 3y squared equals 5. So is that really 5y squared? That's cool. 5y squared equals 5. Divide your 5s. And y squared equals 1. So square root, and y equals plus or minus 1. Do not forget the plus or minus. Do not forget the plus or minus. So knowing what y is, we got to back up and figure out what x is. So when y equals 1, we can find x. That means x equals negative 2 times 1, so x equals negative 2. For y equals negative 1 in the plus or minus, x equals negative 2 times negative 1, so x equals 2. So we have two solutions. We have the solution negative 2, 1, and we have the solution 2, negative 1. Why are there two solutions? Well, if you look at this object, that object is an ellipse. You don't know that when you're doing chapter 9, but if you've looked at chapter 10, you know that's an ellipse. This is a line. You should know that. How many times does a line pass through an ellipse? Well, twice. This one apparently does it at 2, negative 1 and negative 2, 1, which means my diagram might be backwards, but that's okay. So we should have expected really two solutions to this problem. And we got it. See, that was faster. That's good. That's number 3. Number 4 is similar. Xy equals negative 6 and x minus 4y equals 11. Again, because we don't have like terms here, the whole idea of elimination method by adding them won't help, because we're never going to be able to get rid of the x's because we don't have x's to add. We only have xy's to add. So substitution. Excuse me. Again, you could solve for any of your variables. You could solve for this x by dividing off your y, or this y by dividing off your x. But it would probably be easiest to solve for this x. But again, that's up to you. So x equals 11 plus y. Sorry, 4y. Substitute that back into the other equation. So x is now 11 plus 4y times y equals negative 6. So distribute that y, 11y plus 4y squared equals negative 6. And I'll put that in standard form and subtract the 6. Sorry, add the 6 over. Equals 0. And you've got a quadratic. You guys know how to solve quadratics. Heck, that might even be factorable. Is that factorable? 4y, 0 and y, and 3 and 2. That would be 8, and 3 is 11. Yeah, it's even factorable. So your solutions are y equals negative 3 fourths, and y equals negative 2. Cool. So take those, plug them back in, say to here, to find x. I can't help it, I just want to do that. So x equals 11 plus 4 times negative 3 fourths. The 4's cancel, so x equals 8. So one of your solutions should be 8 and negative 3 fourths. Plug that one in. So then x equals 11 plus 4 times negative 2. So x equals 11 minus 8, so x equals 3. So your other point is 3 and negative 2. Oops, sorry. So plugged in the negative 2, simplified down to 3. So 3, negative 2, we got 2 points. Again, we should expect 2 points. This is a rational function, so it looks more or less like that. It's got a line going through it, so it hits twice. You got 2 points, just like you're supposed to. Don't be surprised when these throw out multiple answers. If this wasn't factorable, quadratic formula. Throw it into good old negative b plus minus squared b squared minus 4ac over 2a. You guys should know that formula, of course. And take those decimal approximations, plug it in to find y. Okay. That was number 4. Number 5. Again, very similar type of question. Y equals x squared plus 10x plus 100. And 4x squared plus y equals 175. Here, we're already solved for y. All of this stuff equals y. So wherever we see a y, we can put that. 4x squared plus x squared plus 10x plus 11 equals 175. It's a quadratic in terms of x. You guys know how to solve quadratics in terms of x. 5x squared plus 10x plus 11, so subtract the 175 equals 0. 5x squared plus 10x minus, excuse me, 164 equals 0. And then solve that. Factor it if you can, quadratic formula. If not, you'll get x equals, plug those x equals back into either of those to find y equals. So you'll get some ordered pairs. It's exactly the same process. You guys can do that. Follow through it. The solutions are on the one online. It's done with a slightly different, they're Doug's answers, but they're correct. So you guys can do that. Practice those. But the logic is exactly the same as the others. You end up with a quadratic. Off the top of my head, I'm not thinking that as being factorable, but it might be. Oh yeah, it is. If you simplify it down. Did I write something down wrong? Oh yeah, sorry. It's right there. This is 100. So that's 100. So that's 100. So that's just 75. So it'll factor really nice. Okay. Be careful with mistakes like that. But at that point, at that point you can divide off the 5 and get x squared plus 2x minus 15 equals 0, and that's very factorable. You get what, x plus 5, x minus 3 equals 0, so x equals 3 and negative 5. So those are your x's. Plug those back in to find your y's, and you'll be in good shape. Sorry, that was down there. But again, you guys can handle all that kind of stuff. Those are the skills you guys are good at. Okay, number 6 here. Graph both equations. Okay, so you've got, again, this is talking about finding intersections for graphs. Again, really it's just make sure you know how to graph these things. If you're trying to graph 2x squared minus 4x plus 6, you should know how to graph that. If you've got 4x minus 2y plus 12 equals 0, you should know how to graph that. And then you can find the graphical solutions with your calculator. You can find your graphical solutions by hand. And you can find solutions to this using substitution method or elimination method. But some of the finer points of graphing it, this is a line. You can tell it's a line because all the variables are to the first power. I would be inclined to subtract over the 4x and subtract over the 12. Then divide your -2. So y equals, what, 2x plus 6. And graph y equals 2x plus 6. You guys know how to graph y equals 2x plus 6. If not, figure it out. Your line graphing should be able to handle that, no problem. Trying to graph this, it might be nice to find x-intercepts. You find x-intercepts by setting it equal to 0. I might then divide that 2 off just to make your numbers a little smaller. Hopefully it's factorable. If it's factorable, great. If not, that's fine too. I'm not sure that's factorable. It's not factorable. Well, let me think. Let me look at it. No, it's not factorable. Okay, fine, not factorable. Ooh, it's even going to be complex. Your discriminant is going to be, what, 4 minus 4 times 1 times 3. So that's going to be clearly negative. So it doesn't have any x-intercepts. No x-intercepts, bad. So y-intercept is always the constant, so it's in standard form. So it's 6, so 0, 6. You want to find the vertex, the x value of your vertex, negative b over 2a. Make sure you remember that. So negative 4, so 4 over 2 times 2. So its vertex, x value of its vertex is at 1. To find the y value of the vertex, plug that back in. So the y value of the vertex is 2 times 1 squared minus 4 times 1 plus 6. So the y value of the vertex is 2 minus 4 plus 6. Or -2 plus 6, or 4. Which makes sense if it doesn't have any x-intercepts. So if you want to plot those on your graph, your line has a y-intercept of 6 and a slope of 2. So y-intercept of 1, 2, 3, 4, 5, 6. Slope of 2 means up 2 over 1. Up 2 over 1. So I'm going to plot a couple of points here, just so or down 2, back 1, just so I make sure I'm all neat and tidy. Down 2, back 1. So we have a nice line. Your quadratic has a vertex of 1, 4. So 1, and then 1, 2, 3, 4 right there. And it's got a intercept at 6, so that intercept is right where the other intercept was. That's interesting. It's always nice to have that symmetric point. You go over 1 to get to that intercept, so I'm going to go the other way to get the symmetric point so we can draw some arms. It's nice and tight in there. With that 2 there, we shouldn't be surprised that's fairly tight. So, you want to be able to graph those fairly comfortably and fairly quickly. If you want to then find those intersection points, if you've drawn a very, very nice graph, you can find one of those intersection points is certainly the 0, 6. The other intersection point up here somewhere, 1, 2, 3, and 6, 7, 8, 9, 10, 11, 12. Looks like somewhere around 3, 12. And we could find that more precisely using any of your other methodologies. So that is something you want to be able to do. Okay, how's my time? That time's not terrible. Okay, 7. I want to kind of just set up 7. It's a very kind of standard type of question here. Find the equation of the parabola through those points. Be able to do this by hand. We've already done a type like this by hand, so I might just set this one up and let you practice by hand, but we'll see how much time we have. So -1/8 1, 2, and 2, negative 7. So if those 3 points are supposed to be on a parabola, we know those 3 x and y values are supposed to make the equation y equals ax squared plus bx plus c true. You're even given that that's the equation for a parabola, and that's why it gives it to you. I mean, you should really know that, though, but that's okay. So we have to find the a, b, and c for this particular parabola. And all we know is that if we plug in a 2 for x, this will become negative 7. If we plug in a 1 for x, the y will become 2. And if we plug in a negative 1 for the x, the y will become 8. Well, that's 3 points. We know 3 pieces of information. We need a, b, and c, 3 variables. 3 variables, 3 equations. We should be able to handle that. And again, these points tell us equations. This point tells us that if we put in a negative 1, this thing is going to turn into y equals 8. I'm going to switch the order just so it looks like we're used to. We're also told that if we let x equal 1 plus c, then y equals 2. And lastly, we've been told if that x is a 2, then that y is a negative 7. So we have 3 equations here. They're in terms of a, b, and c, but they're 3 equations with 3 unknowns. We can simplify them a little bit, just because the squaring, so the negative 1 squared just turns into 1, so a negative 1 times b, a minus b plus c equals 8. A plus b plus c equals 2. And 4a plus 2b plus c equals negative 7. That's 3 equations with 3 unknowns. You want to change? I wouldn't recommend changing those to x's and y's, x, y's, and z's, but you could if you really wanted to. And we solved this in exactly the same methodology that you used for the question we did before. Let's see if I can find it here somewhere. Yeah, exactly that same methodology. And see, I had 2.5 minutes. We can do some of it in 2.5 minutes. So again, pick a variable that you want to get rid of. The c's are nice because they're all 1s. The b's are nice because of that negative. We could label them A, B, and C again, but then I'd have to say A, B, and C, and we've got different A, B, and C's. So how about we call them 1, 2, and 3? Really, the labeling is just to help you stay organized. So what do you want to get rid of? Let's get rid of B's. They're kind of already set up. So 1 and 2 together, we don't even need a negative in there. They're already set up that way. So a minus b plus c equals 8, and a plus b plus c equals 2. Add them up, the b's go away just like they're supposed to. So 2a plus 2c equals 10. And since those all have a 2 in it, you might divide out the 2. So a plus c equals 5. So that's equation 4. Now, we have to get rid of b's again. Remember that. You have to get rid of the same variable the first 2 times. So we'll need a 2 times number 1 and number 3. So that'll be 2a minus 2b plus 2c equals 16. And 4a plus 2b plus c equals negative 7. So what, 6a plus 3c equals 9. Again, you might notice there's a 3 in each of those, so 2a plus c equals 3 becomes equation 5. Now again, if you don't notice that there's a 2 in those and a 3 in those, it's fine. Your fractions will simplify later. It's not a big deal. But if you do notice it, it's handy, so it is something I recommend kind of getting in the habit of looking for. Now we have A and C and A and C. 2 equations, 2 unknowns. You guys can solve that. Maybe, I don't know, multiply this by, let's multiply this by -1. So -1 times equation 4. So -a minus c equals -5. And then equation 5, 2a plus c equals 3. So that leaves us with 1a, no c's like we planned, equals -2. So we know a, back it into any of these to find c. So -2 plus c has to equal 5. So c had better be, what, 7? Put both of those into any of those to find b. Let's put into number 2 here. So -2 plus b plus 7 has to equal 2. Is that right? A, B, C, and 2. So b plus 5 has to be 2. So b has to be -3. And remember what we were trying to find. We were trying to find y equals ax squared plus bx plus c. Well, we found the a, -2x squared. We found the b, minus -3x. And we found the c, plus 7. That is the parabola whose graph goes through the points that we were given. Okay. So one more. The other one is almost exactly like that one, so I'm not going to go all the way through it, but I do want to show it to you. And oh, you don't have that one anyway. You don't have number 4 or number 8. Okay. Well, if you want to look at there is a number 8 on the one that I sent out to you. Oh, but it's using those. I'm using circles. It's very much the same type of problem. So those are your reviews for 9. You also have the ones for 5. Good luck. Have fun. I'll be sending the one for the final out relatively shortly. If you have any questions, be sure to let me know.